easily see the level of heat. Understand? Easily you can see the difference in the turbidity. Then you will understand how you can exactly analyze and find out the consistency using the sedimentation.
You are listening to your madam explanation, right? So madam has explained the basic principle behind why the experiment is being done and how to observe it and how to evaluate it, right? Validate it. And also, I would like to also add something with the madam, okay, about the madam explanation. Something I would like to remind you one thing. This is done with a purpose. The pharmaceutical industry, we are doing sedimentation rate for a particular purpose. Can anyone of you can tell me why we are supposed to do this kind of experiment? What is the basic principle behind this experiment? And since I am not asking the basic principle of this experiment, why the experiment is being done, for that there are certain reasons. You understand? There are viscosity, determination of viscosity, there are specific gravity, there are a lot of experiments are there. However, the physical pharmaceutics, otherwise called as, in our terms, I and madam, when we were students, we studied the subject name physical pharmacy. You understand? And has been modified and given to you as physical pharmaceutics, like subject. You understand? Where the physical laws, lot of physical laws will come across. The physical laws are based on the chemical nature of a particular substance. The chemical nature and atomic and molecular nature of a substance will determine the physical properties. The physical properties have very big impact on the formulation. You understand? And their efficacy when they are either topically or internally administered. For example, you may happen to formulate suspension. What is it? Suspension. The suspension usually is a formulation which is an alternative for a solution. A solvent can be mixed with a substance. When it is dissolved to a particular extent, the solution will become so much concentrated, or the solution will have medicament equally distributed, uniformly distributed. When you drop in your mouth 5 ml, the exact quantity will reach your body. Or if you drop 2 ml on your skin and apply, exact quantity will be placed on that, because the substance is in dissolved condition. When a drug molecule which is not dissolved in water and it has to be taken inside or it has to be applied outside, it should stick to our skin for some time, as well as required quantity should be removed from the container when we apply. When these conditions are posing, we need to go for sedimentation rate of a substance. Accordingly, you have to select suspending agent. Suspending agent. Suspending agents are one which will be having both polar and non-polar moiety, and so when it is added in water and shaken, it will give a viscous medium. In that viscous medium, it will prevent the particle from getting sedimented. You understand? So when you shake well, the formulation, whatever the particle sedimented, will come up and will distributed in the viscous medium. You understand? Then when you pour, the required quantity will reach you every time. But when the suspension is like this, and the suspension is having undissolved substantial medicament down, when you pour outside, only this much amount of liquid will come out, which will be having only milligram of medicament. The remaining gram of medicament are here. And so when you shake, the drug molecule should be uniformly distributed in the medium. For that, you have to increase the viscosity. Then only a formulation like a suspension can be prepared and supplied. For that, the student should understand what is sedimentation, what is sedimentation rate, how far every drug is sedimenting fast, how fast they are sedimenting, so how much percentage of suspending agent to be added in order to formulate them. Clear now? Understand? So, madam explained the practical aspect. I have told you in future for what it will be useful.
Applications. So
okay.
has given the
right.
research application.